an ellipse. Defined as the set of all points in a plane such that how do I say this? The sum of the distance, well, distances, right? Sum means what am I going to do? I'm going to be adding some distances. I'm going to be adding the distances from two given points is constant. So one of the differences here is that you have two given points. The two given points, we're going to call them foci. That's the plural of focus. Okay? So today I'm going to have two foci. Here, let me zoom in a little bit so you guys can see this. See, what they're trying to do here is they're trying to come up with an equation of an ellipse. Okay? I don't want to take the time to go through the technicalities with you today. We got pretty technical yesterday. Okay? But what I do want to do is kind of explain, you saw the picture on the board of an ellipse. We're keeping one distance plus another distance always equal to some constant. By the way, you see what they did. They said it's equal to 2a. They didn't tell you yet, or I haven't told you yet what a is, and I'm going to do that. Okay? I will do that. And now, there's also a B and there's also a C. All right, so there's some letters that I haven't explained yet. I will. Now, moving down, the distance formula is everywhere. And at the bottom here, they have a really nice equation. Okay? So here it is. They have this equation that we want to take a look at. I'm going to write it down in my notes for you. Where's my notes? There they are. So if I write down x squared over a squared plus y squared over b squared equals 1, I want to say a few things about it. This is an ellipse centered at 0, 0, okay? So what I mean by that is the center of an ellipse, okay, this is the point between the foci, okay? And then I'm going to tell you one more thing. I'm going to tell you that, well, we have some different letters here, okay? And so A and B are the, well, how about I say this? The distance let's not do it with A and B. Shoot. I'll draw the picture. There's my ellipse, more or less. Here is 0, 0, okay? What I'm going to tell you is that the distance from here to here might be A, and the distance from here to here, okay, maybe I'll make that one in green, would be B. So we have A and we have B. Okay? So now, I can give you guys a few more facts. Oh, and one more thing. There's this letter C. The C is going to be the distance from the center to a focus. C is going to be the distance from a center to a focus. All right. So I really need an example here, and then I can go ahead and help you out. So let's see. I'm looking at, for example, well, number 1 or number 2. I'll go with number 2. So number 2 says x squared over 9 plus y squared over 25 equals 1. And I'm going to pause because I'd like to do this on graph paper. I think it'd be smart. So again, x squared over 9 plus y squared over 25 equals 1. All right. So remember, we're going to have an A, we're going to have a B, and we're going to have a C. Okay? And what I'm saying is that A equals and B equals, well, do you know? B is 5, that's right. And A is 3. Okay. Now, using that information, I can actually already sketch a little bit of a graph of this ellipse. Because remember, A and B are the distances on this picture, the distances from the center to, well, the edge of the ellipse. Okay? So let me go ahead and do that. Let's suppose that this point here is 0, 0. Okay, that's my center, let's say. Well, what I can do is I can say that A is 3 here. So I could go out here to, for example, 3, 0. And what would B be here? We said B is 5, okay? I still remember my old teacher talking about ellipses. So this is the point 0, 5 up here. And he would ask us, is it a fot or a fog? Fot. This one's a fot. A football on the tee. As opposed to a fog. This one's a fog, which is a football on the ground, right? So it's either a fot or a fog. This one's a fot. Because this one, right, if I were to draw the whole thing, 1, 2, 3, 4, 5 down, 1, 2, 3 over. Okay, you have this really nice symmetry. If I were to sketch the whole thing, it's a little more upright than the first one we drew. So that's an approximate picture. Okay. Now I'd really like to draw the foci. And to get that, I need to learn what C is. Okay? And this is where I want to go back to that page in your book that we were just looking at. It was page 519. And so I'm going to look again at a little bit of the technical writing. Whoa! Distance formula used lots of times. Distance from negative C, 0 to 0B, blah, 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 blah. Ah. Right here, guys. Right in there. You see where I'm pointing with my little hand? That's the equation I want. A squared equals B. You know, it's kind of annoying. Because I'm used to the Pythagorean theorem, which says what? That's not the equation you want for an ellipse. Okay? For an ellipse, the equation we want is A squared is the big one. Okay? So A squared equals B squared plus C squared. Okay? That's the equation I use. Yep. A squared equals B squared plus C squared is what I'm going to use. So now, well, we fill some stuff in, right? So we have 3 squared equals 5 squared plus... No. Is that right? Time out. That wouldn't work. To help you remember it, so you don't do what I just did and get them mixed up, let me give you maybe an easier way to remember it. Okay. C squared equals the difference of the other squares. Let's use that as our equation. C squared is the difference of the other squares. In other words, of course, difference meaning what? We're going to subtract. Okay. So we're going to do C squared equals, what's that? That's all right. So I know I'm going to subtract, right? It's either A squared minus B squared or B squared minus A squared. I'm given both of them, right? I guess my point is you have to put the big one first. Does that make sense to you guys? It has to be 5 squared minus 3 squared, not the other way around, which is what I would have gotten doing it the other way. Okay? So it's not always, maybe this is the easiest way to remember it. C squared is the difference of the other squares. So now, work out what you get. C squared equals 25 minus 9. C squared equals 16. So what's C? Sure. I guess it's plus or minus 4, right? But we're going to take the positive in a sense. Although it's interesting, because what I want to do now is I want to plot the foci. So the foci, you kind of have to know where they're going to be. Think about if we were drawing this with a string. Where would we want to put the fingers? Well, you'd put one up here. How far? Right there. What's that point going to be? 0, 4. Yeah, the foci are going to be the points 0, 4. And what's the other one going to be? 0, negative 4. That's right. You'd go down 4. And you'd bear it right there. That's right. On the wider one. And that's why the way our book does it, some books say A is big numbers, B is small number. Okay? Stitz and Zager, they don't do that. They always put the A under the X and they always put the B under the Y. And that's fine. What I want you to remember is that C squared is the difference of the other squares. If you remember that, you just have to remember to put the bigger number first. And then you can get things. Okay, so what else do I want to tell you? Oh, 2 more definitions. Okay? Because they're going to ask you to find some things. They're going to ask me to find the length of what's called the major axis. And they're also going to ask me to find the length of the minor axis. Okay? I guess I should give you the general formula for those. Okay? So maybe we could write this down. In general, the length of the major axis is, to quote Shakespeare, 2b or not 2b. Well, 2a. It's one of those. It's either, and does that make sense to you? In the picture of the first one I drew, the fog, the major axis would be 2a. Does that make sense to you guys? Major means greater, minor means smaller, right? So let's go back to our example we're working on. What's the length of our major axis? Well, I guess you have to realize we're going all the way down here to, this is 0, -5, right? And that's 0, 5. So what's the length of the major axis? 2 times 5, which is 10. Okay, that should be pretty apparent. And the length of the minor axis is going to be, which is 6. Okay? So this gives you a pretty good idea of what the ellipse looks like. Okay? And there's only one other thing that we will do, and that is, remember how I changed the shape by having them move the foci? You guys remember that? Okay? There's a measure that kind of tells you what the shape is like. Okay? And this is done, I've seen this done in astronomy classes when you're talking about, say, the orbits of the planets. All right? So here's the last thing we need. It's called eccentricity. Never thought of that. The root word must be eccentric. But I'm not exactly sure why. So we're going to denote that lowercase e. Eccentricity. And what it is, it's, well, the distance from a center to a focus is what your book says, but we have a letter for that. What's the letter that represents the distance from the center to the focus? C over, well, now it says the distance from a center to a vertex, okay? How about I just say A or B, whichever one is larger. In other words, in our example, what are these numbers going to be? Well, C we know is 4. 4 what? 4 over 5. Okay? So the eccentricity tells me how much like a circle is it? And when I say that, here's what I mean. Remember how Abby and Jim made their fog more like a circle? What did they make smaller and smaller? See, what they did to make it more like a circle, remember, they had this kind of an ellipse, and they had the foci here and here. And then what did they do next? When they brought the foci closer, right, they got more of this kind of shape. And we said if they brought the foci together, you'd actually have a circle, right? So what is it that they were shrinking? Which letter? Well, C was shrinking. Okay? So if C shrinks all the way to 0, then E equals 0, and we have a circle. Okay? Whereas, if you get a larger number, you're getting a stretched out. This is kind of how stretched out the ellipse is. Does that make sense? By the way, this number will never get larger than 1. Do you know why? Well, because, look, when I measure my distance to a focus, the other letter, A or B, whatever it is, B in this case, always has to be a little bit bigger, right? So this is a fraction. I guess what we can say is that 0 is less than E is less than 1. If you get close to the 1, you're very stretched out. If you get close to 0, you're more like a circle. try number 9 here. So you may want to write it down first. We have 9x squared plus 25y squared minus 54x minus 50y minus 119 equals 0. And basically, I'll show you the picture. We want to find everything about that equation. We want to find everything we can that I just learned today, all these different vocabulary words. You know, one of the first questions I have that is not part of his vocabulary, is this a fot or a fog? I'd like to know. All right? I can't tell. Well, maybe I can tell. I have to think a little bit or do a little work here to decide. But let me show you a little bit of strategy. Okay. So one of the first things we're going to do when we get a problem like this is we're going to group the variables. Do you understand what I'm saying? I'm going to write a parenthesis here, and I'm going to write what? 9x squared oh, maybe I shouldn't do the parentheses quite yet. Yeah, let's leave that parentheses out of it just for a second. But let's put the 9x squared there. Let's put the minus 54x here. Let's leave some room. Let's write the 25y squared here, minus 50y here. Let's leave some room, and we're going to say this equals what? Let's bring the 119 over to this side. Okay. Now, next step. Divide. Divide by what, though? You're thinking of the completing the square part. I am going to do half of the coefficient of x and eventually. But what you missed yesterday. Right now the numbers are really big. And another thing that I don't like is I don't like that there's a 9 in front of this x squared. You guys with me? I don't like that. So let's divide by it, right? Let's divide both sides by 9. We'll divide everything by 9. Is that cool, what I just did? It is, isn't it? That's all right. I'm okay with that. All right, let's see what I have now. I have x squared minus what? 6x plus. All right, instead of writing it each of these separately divided by 9, I'm telling you I don't really care. I'm going to write it this way. I'm going to write, well, okay, we'll leave them separate for now. This might make more sense. 25y squared over 9 minus 50y over 9. You're right, Barb, that doesn't really cancel. Equals 119 over 9. Okay, and now let's deal with what Barb was talking about. Let's get rid of that 25 in front of the y squared. What am I about to do? I'm going to divide everything by what? 25, okay? So let's see how this works. I'm going to divide this stuff by 25. I'm going to divide this by 25. I'm going to divide this by 25. I'm going to divide this by 25. In other words, I'm just putting a 25 in every single denominator. Let's see what happens. I get x squared minus 6x over 25 plus, well, what happens here is the 25's cancel, so I just get what? Y squared over 9 minus, do you see what I get here? 2y over 9, okay, equals, now this is ugly, so I'm just going to leave it for now as 119 over 9 times 25. I know that eventually I may want to compute that, but I don't want to right now. Okay. So, we're about ready to complete the square, I think. Okay, in the different places. Let's do a redo. Okay, very first step we did was divide by what? 9. I was cool up to here. Let's rewrite what that looks like when you divide everything by 9. Just because it's going to be easier this way. X squared minus 50, oh no, it wouldn't be 54 anymore. It would be what? 6x, okay? Let's leave a space. And now I have, okay, plus 25 ninths y squared minus 50 ninths y equals 119 over 9. Let's see how this looks. Let's try it. Okay. We have to complete the square. Do you guys know at this point what I need to do here? Plus what? 9 is correct. Should I work it out? Half of negative 6 squared. That's negative 3 squared. It's 9, right? So I add 9 here, and I also add 9 where? Over here. 9. All right. So let's see what we have. We have, this is going to be x minus what squared? 3. Plus, well, remember, another way to write this is 25y squared minus 50y over 9. And how do you write 9 as a fraction? I probably should have done that. 9 over what? 9 over 1. Can you add those fractions then? Well, not yet. What do we have to do first? We write 119 over 9 plus, yeah, multiply this by 9 over 9 and we get 81 ninths, okay? All right, so now it's getting a little bit nicer. I have x minus 3 quantity squared plus, well, I have this 25. Why don't I factor out a 25 here? And then what do I have is y squared minus what? 2y. And now I can add these fractions on the right. What do I get? Do I get 200? That worked out nice. So 119 was a really nice number. 200 over 9. All right. And I'm getting ready to complete the square in there eventually. But before I do, I'd like to get rid of all the fractions. So if I get rid of all the fractions, how do I do that? Multiply by 9, sure. So multiply everything by 9. And now I have 9 times x minus 3 squared plus 25 times y squared minus 2y, we'll leave that blank, equals what? 200. And again, I'm still getting ready to complete the square, but what I'm going to do now is divide everything by what? I'm not quite ready to complete the square because I'd like to get rid of that 25, right? So let's divide by what? 25. Okay. So let's see what we have. We have x minus 3 quantity squared. We have a 9, well, times 9 25ths in front of it. Right? Okay. Plus, here I have, well, y squared minus 2y, and I still have that blank. And what do I have here? 200 divided by 25? Yeah, that's 8, because I know there's 8 quarters in $2. Okay. Getting there. Now what? What goes here? Plus 1. And again, I'm sure you can do that by now, because we've done it so many times. All right, so we're almost done. Let's see. I have 9/25 of x minus 3 quantity squared plus y minus 1 quantity squared equals 9. And now, what am I going to do to both sides? We're going to divide by 9. Why? We got to set this equal to what? Set it equal to 1. We have the squares completed. We got to get it set equal to 1. So let's divide everything by 9 and see what it would look like. What would the first piece become? X minus 3 squared. Yeah, you could just write over 25. Because it's times 1/25. Plus, how about the next piece? There it is. Equals 1. That looks really nice, and now I'm ready to sketch a little graph and go home, right? But let me ask this, because I'm out of time. I don't have the time to sketch the graph exactly. But what kind of football are we going to have? A fought or a fog? What? This is on the ground. How do you know? A's bigger, the major axis. You know what the picture is? Almost. Notice it's the 25 and the 9 again. It's almost, that's the picture. The only thing different is, where is this thing centered? The center is at 3, 1. Nice job today, guys. I'm going to do the same thing. I'm going to group the x's together. I'm going to group the y's together. I'm going to make room for, yeah, but this time I am going to, remember I almost put parentheses? You guys remember that? Well, I'm putting them. Okay, 25y squared minus 50y. And let's put the 119 on the other side. I like this a little better. And then I was like, no, I want to divide out. Well, okay. I think a better move here is to factor. Okay? Find the greatest common factor for the x's. Find the greatest common factor for the y's. This is problem 9, which means the numbers are nice. Sometimes they won't be. All right? Like, I'm going to pull out a 9 here, and what am I going to get in there? X squared minus 6x. Because 54 divided by 9 is 6, right? Imagine a problem that said this. Imagine a problem that said 9x squared minus 31x. Well, now if you factored out the 9, you would get x squared minus, do you know what you would get? 31/9 x. Does that make sense to people? I want to show you because sometimes we get more challenging problems. And then when you complete the square, you'd have to take half of 31/9, so I guess that'd be 31/18, and then you'd square that. All right? This makes sense to people? Okay. I want to show that because sometimes that happens on these homeworks. Let's see. Plus, what happens here? Take out the 25, and we have y squared minus 2y. And all this equals 119. Now, these numbers are easy enough that I think we could complete the square without writing much down. Okay, so I'm going to go ahead and try and do that. I'm going to use a red marker here. Tell me what I have to write to complete the square. Let me go through it orally. Half of 6 is 3. When I square 3, I have, okay, so I need to write plus 9. But Whatever you do to one side, you must. But what did I really do to the left-hand side? I didn't add 9. I added 9 times 9. You guys see that? What did I really add? 81. And by the way, yesterday, when I did all this dividing, it was to try and avoid that worrying about what I really added. When I completed the square yesterday, I added 9 to both sides. When I completed the square yesterday, I added 1 to both sides. But, boy, it was a really long problem. Let's go back to what we're doing here. I think this is not too bad this way. Let me get the purple marker out. What is it I want to add inside this little parentheses? Let's say half of 2 is 1. When I square it, I get 1, so I add 1. But what did I really add? So I add 25 over here. Bless you. I don't think that's too bad. I think that works out pretty nicely. Okay? So now, let's see what we can do. And I have 9 times x minus 3 squared. I hope you guys are getting better at that. Okay, we did it yesterday. Plus 25 times y minus 1 squared equals, and this whole thing equals, what does it equal? 225. Okay. Which means, next step, divide by. We could divide by 9. We could divide by 25. But remember what I'm really trying to do? Once I get the squares, I basically want to set the equation equal to what? To 1. So you know what I really want to divide by? 225, which happens to be 9 times 25. This problem is extremely nice to you. Do you guys understand how nice he was for this one? He got it to work out so that when you divide everything, you can barely see that, can't you? When you divide everything by 225, I feel like I'm at the tribe game with guys on base, you know? You told me 9 times 25 is 225, so this is going to be x minus 3 squared over 25 plus y minus 1 squared over, what, 9 equals... This is a lot faster than yesterday, okay? It's just that you have to pay attention here, so I'm glad you guys came up and suggested this. This is what I normally do. I wanted to make sure I show that. Okay. Oh, I want to take a timeout. Timeout? Suppose I had been given this equation. Let me write it here. This is a suppose. 9 times x minus 3 squared plus 25 times y minus 1 squared equals, suppose it already equaled 1. This is a suppose. Would I be done? Yeah, almost. Remember, I really wanted to say x minus h squared over a squared. Like this equation here is nice. We're going to graph this one in a minute. But I want you to think about what would you do in this case? Because that's interesting. All right. Graph paper time. Let's get some graph paper. And let's sketch a graph. Where are we going to go? What's the first thing I should plot for that rectangle equation? Yes, we want to plot 3, 1. That's the what? The center. Okay. So let me do that. I have some axes here. You can see that. Okay. And so I want to go to 3, 1. And that's right here. That's the center. The center is 3 comma 1. This is number 9. Okay, what else do we want? Well, at this point, I'm going to go ahead and take a look at this a squared. A squared is 25. So a is 5. And what that tells me, oh, what does that tell me? Go where? Well, because it's under the x's, that's telling me to go left and right. I'm going to go right 5. Yeah, Dale, this is just the one from yesterday. We kind of redid it. We're graphing it now. 1, 2, 3, 4, 5. Does that make sense to you guys? When a is 5, that tells... a squared was 25, so a is 5, so that says move out 5 in each direction. Okay? What do you think I'm going to do next? Up 3 and down 3. That's right, because y squared is 9, so y is 3. There we go. You guys follow? And I'm telling you that the ellipse looks something like that. Something like that. It is a fog. Right? What else can I say about it? Oh, remember how we drew this was we had to have the two what? Foci. So I'd really like to know what the foci are. To get the foci, I want to look for the letter, oh, why did I say y? This isn't y. What is this? B squared and b. Thank you. Okay, so to get the foci, I really want to know what the letter c is. C squared is equal to what? The difference, right, the difference. So c squared in this case is going to be 5 squared minus 3 squared, which is 25 minus 9. And again, it worked out really nicely. C squared is 16, so c is, yeah. And if you want to say plus or minus 4, I'm okay with that. I think the book will say 4. But that tells me where are the foci? Well, I guess I have to go out 1, 2, 3, 4 in this direction and go back 1, 2, 3, 4 in this direction. How do I know to move horizontally? That's the major axis, right? It depends which number is bigger. The foci are going to be along the major axis. Okay? Yeah, it would. It would leave the ellipse, and you know that's not right. Okay. So what happens here, let's see, if I had to actually list the foci, what are the coordinates? Well, there's 2 of them. I know the y-coordinate. What's the y-coordinate? It's the same as the center, right? So that's going to be 1. Now for the x-coordinate, I guess I have 3 plus 4 is 7, and 3 minus 4 is negative 1. Is that okay? And if that's 7, 1, then this vertex, they call it, is 8, 1. And this vertex is negative 2, 1. Whereas these points would be, I guess, 3, 4, and 3, negative 2. All right. Is there anything else you guys had to find last night with this kind of a problem?
C over whichever bigger A or B.
Yeah, so in this case, E is going to be, well, C over A, and so it would be 4/5, just like that other one we did. I think the first example I did, it was 4/5. Okay, 4/5 is pretty close to 1, so it's starting to get kind of flat. When we're close to 0, we're getting circular. What else? Oh, remember the new problem? Let's talk about that one for a minute. Suppose I have this equation. What would that look like? Well, the problem is you don't know what A and B are, do you? All right? So I can show you a trick. Okay? Here's the deal. Multiplying by 9 is exactly the same as dividing by something. Dividing by what? 1/9. Does that make sense to people? Plus, and then do you know what I'm going to write next? Y minus 1 squared over 1/25 equals 1. So now I know a squared is 1/9. And I know b squared is 1/25. So what does that tell me? That tells me a is 1/3 and b is 1/5. So this is a teeny tiny ellipse. You have 15 seconds to quiz your neighbor on if it's a fot or a fog. Hey, what's bigger, a third or a fifth? A third is bigger, so this is a third from here, the center to the edge of the ellipse, but this is only a fifth, so I'd call this a fog, right? A football on the ground. Not a frog, a fog. Okay? And that's not a technical term you'll find anywhere else, I don't think, but you were talking about completing the square, so I'm sure you did this. You did 9x squared plus, you brought the 8 to the other side to make room. Did you factor out a 4? Divided by 4? Remember, I did that the first time, and then I was like, wait a minute, there's an easier way. So let's try it this way. Let's factor out 4 from the little pieces that are left, and let's see what we have. We have y squared, and then what else would I have here? Minus y, right? Okay, Wayne, I'm zooming in on this one now because I don't get the graph. Is this better? Okay, so minus y, and now I have to figure out how to complete the square, right? So let's see. What goes in here? Half of something squared. Half of what? Okay, of 1, or negative 1, right? So I'm going to be taking a half and squaring it, and when I square a half, I think that's what Barb said, is we get a fourth, right? So let me try this. I'm going to write down plus 1/4, but this is where it's weird. I didn't really add a fourth. So don't put plus a fourth over here, because that's not what you really added. What did you really add? Right, because you added 4 times a fourth, right? So we're really adding 1. Hopefully that's enough to... Yeah, let's write the next step. 9x squared plus 4 times, and what would this be? Y minus, you're right, 1/2 squared, because a half times a half is what gives you the fourth, equals 9. I'll keep going. What do I do next? Divide both sides by? Okay, I'm good.